Inverse of a 2 by 2 matrix. If matrix A contains the elements A, B, C, and D, and the determinant of A is not equal to 0, then the inverse of A is equal to 1 over the determinant of A times the matrix with elements D, negative B, negative C, and A. Notice that we swap the positions of the elements in the main diagonal. A, D, and then D, A. We change the signs of the elements in the other diagonal. This is positive B, positive C. This is negative B, negative C. Example number 1. Find the inverse. Matrix A contains the elements 6, negative 7, 4, and negative 5. Step number 1. Find the determinant. The determinant of matrix A is equal to, change the bracket to vertical bars and then copy the elements 6, negative 7, 4, and negative 5. And then find the product of the elements in the main diagonal. So 6 times negative 5, and then minus the product of the elements in the other diagonal. So minus 4 times negative 7. This is now equal to negative 30 plus 28. This is now equal to negative 2. So the determinant of A is equal to negative 2. Step number 2. Find the inverse. The given matrix is the matrix A, which contains the elements 6, negative 7, 4, and negative 5. The inverse of A is equal to 1 over the determinant of A times, swap the positions of the elements in the main diagonal. So we have negative 5 and 6. And then change the signs of the elements in the other diagonal. Positive 4 becomes negative 4. Negative 7 becomes 7. The determinant of A is negative 2. So this is now equal to 1 over negative 2 times the elements negative 5, 7, negative 4, and 6. We distribute 1 over negative 2 or negative 1 over 2 to each of these elements. So this is now equal to negative 1 over 2 times negative 5, negative 1 over 2 times 7, negative 1 over 2 times negative 4, negative 1 over 2 times 6. This is now equal to negative 1 over 2 times negative 5 is equal to 5 over 2. Negative 1 over 2 times 7 is negative 7 over 2. Negative 1 over 2 times negative 4 is 2. Negative 1 over 2 times 6 is negative 3. This is the inverse. Example number 2. Find the inverse. Matrix A contains the elements negative 7, 8, negative 3, and 4. Step number 1. Find the determinant. The determinant of A is equal to, change the brackets to vertical bars and then copy the elements. So this is now equal to vertical bars and then negative 7, 8, negative 3, and 4. And then find the product of the elements in the main diagonal. So this is equal to negative 7 times 4. And then subtract the product of the elements in the other diagonal. So minus negative 3 times 8. This is now equal to negative 28 plus 24. Negative 28 plus 24 is negative 4. So the determinant of A is equal to negative 4. Step number 2. Find the inverse. The given matrix is matrix A, which contains the elements negative 7, 8, negative 3, and 4. The inverse of A is equal to 1 over the determinant of A times swap the positions of the elements in the main diagonal. So we have 4, negative 7, and then change the signs of the element. Negative 3 becomes positive 3, and positive 8 becomes negative 8. This is now equal to, the determinant of A is equal to negative 4. So this is 1 over negative 4 times the elements 4, negative 8, 3, and negative 7. We distribute 1 over negative 4 or negative 1 over 4 to each of these elements. So we have now negative 1 over 4 times 4, negative 1 over 4 times negative 8, negative 1 over 4 times 3, negative 1 over 4 times negative 7. This is now equal to negative 1 over 4 times 4 is negative 1. Negative 1 over 4 times negative 8 is positive 2, or we just write 2. Negative 1 over 4 times 3 is negative 3 over 4. Negative 1 over 4 times negative 7 is positive 7 over 4, or we just write 7 over 4. This is the inverse.